electrostatics.
Yes, ma'am.
Yes, basics. We will look from grade 10.
Yes, ma'am.
All right.
Yes, ma'am.
Then electrostatics. Yes. You must remind me, can you recall what is electrostatics?
Isn't it the transfer of electrons between two objects?
Under electrostatics, we say it is the study of static electricity where we try to find out what effect do charges at rest have on each other. So here we are studying charges that are at rest. Take note of the word static electricity. Can you see that word, static electricity?
Yes, ma'am.
Yeah, let us isolate it. Static electricity. We have two kinds of electricity. Current electricity, the one we studied using circuits where charges flow through a conductor. Then we've got static electricity. This one, charges built on the surface of the object. They are stationary, all right?
Yes, ma'am.
Yes, they don't move through a conductor. Remember, we've got two kinds of charges. We are just recapping on grade 10 work.
Yes.
Two kinds of charges. Can you give me the name of the first one? Any?
A positive charge.
Positive
Charge.
charge. Then the second one?
Negative charge.
Negative
Charge.
charge. All right.
Yes, ma'am.
So since we said here we are starting two kinds of charges, it means we've already started talking about charge. Let's look at a charge. Yeah, a charge. It has a symbol. Can you tell me what is the symbol for a charge?
Q.
What is the symbol for charge?
Q.
It's Q. Good. So a charge, it is, you can define it. It is the measurement of the amount of electricity an object has. So we say the symbol is Q. The symbol is Q. Then what is the standard international unit?
For each charge.
Yes.
Your believe.
It is coulombs.
Oh, yes, Coulomb.
Yes. coulombs. Then symbol for coulombs is capital letter
C.
So this is the charge, and we've looked at the two kinds of charges that we have: a positive charge and a negative charge. So we are also going to look at these two charges now. We're gonna unpack them. When does a positive charge form? When does a negative charge form? So let us look now at a positive charge. Positive charge. Positive charge, it is formed when there is loss of electrons. Yes, we must remove electrons from a neutral object. Then we will have a positive charge. When there is when it's a positive charge or positively charged object, we can say here there is a shortage of electrons. There is a shortage of electrons / electron deficient. This one is electron deficient. It means there are more positive charges than negative charges. All right. So if we draw a picture of this kind of an object, if we draw it, it will look like this. Just because I am positively charged doesn't mean I don't have negative charges. All right. Yes, ma'am. So if you look at this object, let's say here is our object. Check it out. You can see each object, each positive charge has a negative next to it to make it neutral. Now, can you count for me? How many positive charges are here?
5.
5.
Yes, ma'am.
So we've got 5 positives.
Yes, ma'am.
Okay. How many negatives?
Yes.
We've got 3. All right. So if you were to calculate the net charge here, remember negative, we'll put a negative here next to 3, -3, +5, positively charged. Okay. If you were to calculate now the net charge of this particular object, what will be the net charge? It's +5 plus -3.
Yes.
What is the answer?
Is about 2. Positive.
It's going to be +2. So you can see this object, it has got more positives than the negatives. All right.
Yes,
It means next to this positive, an electron was removed, was taken away.
yes, ma'am.
Okay, are we together?
Yes, ma'am.
All right. Then let's look now at a negative charge. Negative charge. A negative charge is formed when there is a gain of electrons. Okay? This one must gain electrons. So on this one, there is excess
Yes, ma'am.
electrons. There are additional electrons that are coming from another object.
Yes, ma'am.
So here we've got more negative charges than positive charges. So if we draw a picture like what we did for a positive one, this is what we will have.
Yes, ma'am.
So we draw a picture. We'll have something like this. Remember, objects are neutral.
Yes, ma'am.
Yes. If you look at my language, I don't say we add protons, the positive charges.
Yes,
If you hear me well, I talk about electrons being added, not protons being added. So from this diagram, you can tell me how many positive charges do we have?
positive 5.
We've got 5, positive 5. How many negative charges do we have?
And
Hmm?
negative 8.
Negative 8. Awesome.
Yes.
Then tell me, what is the overall net charge? You can say overall net charge or net charge.
Possible negative 3.
Negative 3, ne?
Yes, ma'am.
So overall net charge must prove it. It's going to be negative 8
Negative
plus
is 5.
5, which will give us negative
Negative
3.
3.
So you can see that it has got excess of 3 electrons. Remember, positive charges are called protons. Don't forget
Yes, ma'am.
protons. And if we talk of protons, where are they found in the nucleus?
Protons.
They are found at the center, in the atom.
Yes.
They are found in the atom, they are found at the center. They are found inside the nucleus, the positives, protons. Hence, they are stuck there. They are unable to move. But negative charges, we call them electrons, and they are found outside the nucleus and they orbit, they move around the nucleus. Hence, they are the ones that are moving. So electrons move. And when they move, we've got electricity. Electricity. See the word electricity?
Yes, ma'am.
Yes, it comes from this word electrons when they are moving, all right?
Yes, ma'am.
So electricity is the movement of charges. And which charges are moving? It's electrons, all right? Remember that. Okay. Then we've got this particular object, which we call, it's a neutral object. I want you to understand the terminology here first before we engage in calculations. A neutral object. Neutral object. You know this neutral object? It is the object that has equal number of what?
Electrons and protons.
Yes, of protons and electrons, or electrons and protons.
Yes.
Same thing. So this one, it doesn't have extra electrons or extra protons. Let's look at it, for example, right now. Each positive is paired to a what? A negative.
Yes, ma'am.
Yes. So if you check this object out, how many positives are here? And how many negatives are here?
There's 5 positives and there's 1, 2, 3, 4.
There's also 5
Yes, ma'am.
negatives. Okay.
Yes.
All right. Then which is equal to negative 5. Then if you calculate the net charge, what is the overall net charge?
Net charge. Net charge.
Net charge is negative 5 plus, which is equal to 0. So you can see that this object is neutral. Are we cool?
Yes, ma'am. Yes, ma'am.
Oh, all right. Then let us now move on. Now we've got the principle of conservation
Charge.
of charge. What does it say?
The net charge of a closed system stays constant during any physical change.
Yes, it is the one. Tell me, what does it say?
The net charge of a closed system stays constant during any physical change.
Yes. The net charge
Of a closed system.
yes, of a closed system
Stays constant.
Stays constant, yes,
during any physical change.
during any physical process, is it?
Yes, ma'am.
Yes. In simple words, others they will say, what was the old one that says charge cannot be created nor destroyed, but can be transferred from one object or from one charge to the other. You can remember that one.
Yes.
That charges cannot be created, charges cannot be destroyed, but can be transferred from one object to another. Okay?
Yes, ma'am.
Yes. So, during any physical process, when the charges touch each other, remember charge there can be what? Can be transferred. We can calculate how much charge is transferred. Now, how do we do that? We are looking now at the principle of conservation of what? Of charge. Remember here, if we've got two charges, two charges coming in contact with each other, what is going to happen from them? There will be transfer of what? Of charge. Yes, of electrons or of charge. So when two charges come in contact with each other, what will happen? There will be transfer of charge. Transfer of charge. Transfer of charge, and that charge is electrons that are being transferred. Remember, how does the transfer happen? Charge will move from an object, from a charge that is, or let's say electrons, will move from a charge that is more negative to a charge that is less negative. Okay? So we are going to draw here just a picture that will show us if now we've got two charges that are now in contact. Two charges that are in contact. There is charge 1, there is charge 2. They are in contact. So there will be transfer of charge or transfer of electrons. All right. Once these two charges have touched, remember, electrons now are being transferred. These charges, after touching and then being separated, they will now have the new charge.
Yes,
Did you get that?
yes, ma'am.
Yes. After the two charges have touched each other and then separated, they will now have a new charge,
Yes, ma'am.
which is also called final or charge final charge. Because now, why do we say it's final? Because they did have the original charge, all right, which we call initial charge. Now, after they've touched, they are separated. Now they have a new charge. The symbol that is used for this charge final or new charge, we use Q, new for new charge. If you don't like new like this, you are going to use Q final.
Yes,
This one is one and the same thing.
yes, ma'am.
It's just using different word. Because even for initial, you can say original charge. Okay?
Yes, ma'am.
Then this new charge can be calculated. I will give you the formula.
Yes, ma'am.
This new charge can be calculated using this equation. Let's look at it. It says Q new I must write the new as a subscript. Q new is equal to, if two charges have touched, Q1 plus Q2.
Q2 over 2.
Then you divide by
2.
2 because there's two of them. If there's three of them, you say Q1 plus Q2 plus Q3 divided by 3.
Yes, ma'am.
Or you can say Q final is equal to Q1 plus Q2 all over 2. Are we together, Ketelo?
Yes, ma'am.
All right. So this is how you are going to calculate the new charge. Then, how are you going to calculate now the amount of charge that was transferred during this physical process of touching? Now, charge transferred Charge transferred.
Yes, ma'am.
Charge transferred also can be called charge gained or lost. Remember that during the transfer, one charge is gaining while the other is what? Is losing.
Yes, ma'am.
Yes. So the symbol for charge transferred is change. Change in Q. Change in what?
Thank you.
In Q. So change in Q stands for charge transferred. Okay?
Yes, ma'am.
Yes. So this change in Q or charge transferred can be calculated. I will show you now the formula of calculating the charge transfer or charge gained or lost. Okay? So change in Q can be calculated using, yes, these are grade 10 equations.
Yes, ma'am.
So we are still busy with revision from grade 10 because they do ask these kind of questions even in grade 12 examinations. So Q final minus Q initial. All right, so far we have studied two equations.
Yes, ma'am.
This one of calculating Q final and this one of calculating charge transferred if we want to know how much charge was transferred. Now we're gonna do a quick activity where you are going to implement what we have studied. Okay, since you are already in grade 11, I'm not gonna even do examples. I'm going to give you an activity right now, okay?
Yes, ma'am.
So quick class activity for you. All right. Here in this case, we've got two scenarios, 1 and 2. So these questions are based on both scenario 1 and scenario 2. A quick reminder to you in case you have forgotten, this n, and this mu. A reminder, you know, wherever you see nano, n stands for nano, all right?
Yes, ma'am.
All right, let's do these prefixes. We've got, let me start with milli. If we see milli, if you see, oh, let me start with centi. If you see centi, whether it's a centimeter, centicoulomb or centi, whatever, milli, then we've got mu, which is for micro. Just, I'll give you the substitute. If you see nano, if you see P for pico, you must know each of these. What do they represent? Whenever you see, for example, here, when you see nano, you will replace it. I put it with a times 10 to the power negative 9. All right. Where you see mu, for example, here, you will put, you just substitute there instead of mu, you put times 10 to the power negative 6. If you see cent, even if it's centimeter, it's times 10 to the power negative 2, which is same as divide by 100. If you change centimeters to meters, if you see milli, in millimeters, you just milli, it's times 10 to the power minus 3, which is the same as divided by 1000. Pico, where you see picocoulomb, it's times 10 to the power negative 12. All right?
Yes, ma'am.
Okay. Don't forget units next to your answers. If you are calculating a charge, you know the answer must have coulombs next to it. All right?
Yes, ma'am. Yes, ma'am.
So quickly complete your activity. It's not a difficult one. And you will give me the answers. All right? I will wait on you.
Yes, ma'am.
Notify me when you are done.
Yes, ma'am. Yeah, ma'am, so I'm done.
All right, awesome. Now I need answers for here. You first calculated the new charge using the proper equation. You said Q final
Yes,
is equal to Q1
plus Q2.
plus Q2 all over 2, which was equal to
In the total 5 times 10 to the power of negative 10 coulombs.
okay, 2 times 10 to the power.
5 times 10.
No, we are
Plus 5.
substituting.
Oh,
We are still substituting. Plus 3 times
10 to the negative
10. Okay, let me do something here. Okay, let me remove, push up. This scenario, move it a bit up. Okay, so okay, so we've got negative 2 times 10 to the power negative 9 plus 3 times 10 to the power negative 9 all over 2. You said what is the answer?
That time people negative 5 times 10 to the power of negative 10 coulomb.
Negative 5.
Yeah, 5 times 10.
5 times 10
Yes, ma'am.
to the power.
Of negative 10.
Okay, let me. Oh, yeah. Same as 0, 5 times 10 to the power negative 9. Do you agree that your answer is the same as this one?
Yes, ma'am.
Yes. Okay, that is for scenario 1. It's 1.1. Then for scenario 2, you do the same thing. So we are on our solutions now. You do the same thing. Q final. I'm no longer going to write now the equation because we wrote it first. It's gonna be 2 times 10 to the power negative 6
Yes, ma'am.
plus 3 times 10 to the power negative 6 all over 2. And what is the answer?
And well, 2,5 times 10 to the negative 6 coulomb.
2,5 times 10 to the power negative 6 coulomb. Then for 1.2, you are asked to calculate charge transferred. So symbol for charge transferred is changing
In Q.
Q. Yes. So we start with scenario 1, Q final. But there are 2 initial charges.
Yes, ma'am.
You can use any of the 2, all right? The answer will be the same. The difference is that the other one will be negative while the other will be positive. Okay?
Yes.
So your Q final for the first scenario was 0,5 times 10 or 5 times 10 to the power negative 10. It's up to you, okay? But it's the same. Times 10 to the power negative 9. You can use charge A or charge B. Which one do you want us to use? Let's use A.
Yes, ma'am.
A is negative. Yeah. 0,5 minus 2 times 10 to the power negative 9. What is the answer?
Mm-hmm. 0,00025.
Put it in scientific form.
Okay. To the power of negative 9. So 2,5 times 10 to the power of negative 9.
2,5 times 10 to the power negative 9 coulomb. If you use your Q initial as Q2, which is 3, your answer will be negative. All right?
Yes, ma'am.
It will be negative 2,5. You can try it, work it out yourself. If you use positive 3, your answer will be 2,5 times 10 to the power negative 9 coulomb. All right?
Yes, ma'am.
Then, same thing you do now, calculate change in Q. Ooh, I don't know why I put that final there. Supposed to be change in Q,
Yes,
not change in Q final. This does not. It's not there. So we must remove this. Okay. Then for scenario 2, you use the same formula. Change in Q. It's Q final again. Minus Q initial.
Yes, ma'am.
What is Q final here? It's 2,5.
Yes, ma'am.
Yes, it's 2,5 times
10 to the power of negative 1.
times
Negative
10 to
6.
the power of negative 6 minus, if we use
Yes, and so
our x,
yes, ma'am.
it's 2 times 10
To the
to the
negative
power
6. Negative 6.
negative 6. And what is the answer?
5 times 10 to the power of negative 17.
It is
5 times 10 to the power of negative 17. Negative 7. Negative 7.
so the answer is 5 times 10
Yes.
to the power
Negative 7.
5 times 10 to the power negative 7. All right, or 0,5, is it?
Yes, ma'am.
Times 10 to the power negative
6.
6. You see that it's positive.
Yes, ma'am.
Okay. So this is your change in Q for the second scenario where there are two charges that are hanging. So this is the answer. All right. I hope this is all clear. You can see the charges that have lost. When you calculate charge transferred, it's positive. But for the ones that have gained, when you calculate charge transferred, it is negative. Can you see that the ones that have gained become negatively charged? Or the change, the charge transfer is negative. Can you see that?
Yes, ma'am.
All right, not that they become themselves become negatively charged, but you can see the charge transfer is negative if it has if we use the initial charge that has gained. The one that has lost, and we calculate the charge transfer for that one, it's positive. Okay. Now, from what I have said, I believe you can now answer 1.31 and 1.32. The direction in which electrons will flow. Are they going to flow from A to B or from B to A?
A to B.
A to B. So the option here is A to B because A is more negative. All right?
Yes, ma'am.
Yes. Then 1.3.2 from X to Y or Y to X.
X to Y.
X to Y, they will move from X because X is less negative. I is less positive, which means it has got more electrons than Y. So charges will definitely move from X to Y when they touch. Here they will move from A to B when they touch. That's how electrons will move. Okay, that's how the charge will flow. I hope you are clear on this, on the use of the two equations that we talked about.
Yes, ma'am.
Okay. One more thing, I'm not gonna wrap off these scenarios because I'm going to need them. So that we are quick, I'm gonna paste some information here regarding charge quantization. Charge
Quantization.
quantization. Have you heard of that term?
Yeah, I'm saying that.
Yeah, in grade 10.
Yes, ma'am.
Yeah, all charges, they occur in the multiple, integer multiple. It's a number, integer multiple of 1,6 times 10 to the power negative 19 coulombs. All charges, they occur in the integer multiple of this number 1,6. All charges in the universe, they consist of this integer multiple. So that is the principle of charge quantization. If you are asked to state it, is that all charges in the universe consist of an integer multiple of the charge of an electron, which is 1,6 times 10 to the power negative 19. Now you are going to apply this principle of charge quantizations in solving problems. Here is our equation. Q, we said all these charges, they occur in this integer multiple. N, that is our number here, we are going to be multiplying with times this elementary charge. I call it an elementary charge, or if you don't like to use Q, E, you can say N times E. You know this E. This E stands for, or QE stands for elementary charge.
You only charge of an electron then?
I will talk about that. This is an elementary
Yes.
charge. Elementary charge is 1,6 times 10 to the power negative 19 coulomb. You must be able to define what the elementary charge is. Elementary charge is a charge of a proton or electron. Did you get that? It is a charge of a proton or electron. All right, so if it's an electron, it's gonna be negative 1,6. If it's a proton, it's gonna be positive
1,6 times 10 to the negative 19.
Yes. Please keep those numbers in mind. Okay. So if it's a charge of a proton, I'll just write them. It's gonna be positive 1,6. So if you are asked, what is the charge of a proton? It's 1,6 times 10 to the power negative 19 coulomb. Remember, protons are positive charges. If it's an electron, we said it's gonna be what?
Negative.
Negative 1,6 times 10 to the power negative 19 coulomb. Okay? So there is this equation now that you have learned. They give you in the data sheet. How they write it in the data sheet, we can make n the subject of the formula. So this formula can be written in this manner. This same equation can be written in this format, where we can say n is equal to Q over E. Q over E. That E is the charge of an electron or charge of a proton. Can be written in this manner. You'll find it in the data sheet. What does N stand for?
N.
Number of electrons.
Tron.
Okay?
Yes, ma'am.
N stands for number of what? Of electrons. Yes, Q stands for charge. E stands for elementary charge. Remember, if your charge at the top is a positive charge, it means you will use the charge of an electron, of a proton man. All right? If your charge is a negative charge, you will use the charge of a what? Of an electron. Are we together on that one?
Yes, ma'am.
Now I want you to use this equation to calculate the number of electrons on each of these charges, all four of them, A, B, X, and Y. Can you do it quickly for me? Then you give me the what? The answers. All right?
Oh, yes, ma'am. Done now.
You can see the questions catalog that I've added.
Yes, ma'am.
Because afterwards you will guide me on the steps that you did to solve each of those problems. All right, let's do it quickly together.
Yes, ma'am.
The first one, A, it's -2 times 10 to the power -9 divided by -1 comma 6 times 10 to the power -19. What's the answer?
1,25 times 10 to the power of 10.
1,25 times 10 to the power 10.
Yes, ma'am.
Yes, so this is the number of electrons you have, electrons.
Yes, ma'am.
Then for B, you do the same thing, 3 times 10 to the power -9 divided by 1 comma, there's no negative because it's a proton, is it?
Yes, ma'am.
Yes, so every time you calculate the number of electrons, you'll always get a positive answer, and it's big. All right, what is the answer?
The answer it is
What is it?
1,875 times 10 to the power of 10.
1,875
Five.
times 10 to the power
Negative
10
to the power, yes, power of 10.
electrons. It's positive 10.
Yes, ma'am.
Yes. Then let's do for X now. N is equal to 2 times 10. The answer for X is going to be the same as this one. No, because it's times 10 to the power -6. Almost made a mistake. What is the answer?
For X, the answer corner it's 1,25 times 10 to the 13.
Times 10 to the power?
Of 13.
Oh, correct. 1,25 times 10 to the power 13 electrons. Okay, this is the number of electrons. Then for Y, what will be the answer?
Why?
One,
Answer will be 1,875 times 10 to the power of 13.
yes, 1,875 times 10 to the power 13. Finish it, yes. The work, all right. Then let's do now 1.5. Can you read for me the question for 1.5?
Calculate the number of electrons of the final charge in each scenario.
You remember the final charge in each scenario?
Yes, ma'am.
Okay, we'll only have for scenario 1. For scenario 1, where we added A and B and divided by 2. So the final charge now for this scenario 1. Scenario 1. So what was the final charge?
We go 5 times 10 to the -10.
Yes, 5 times or 0,5 times 10 to the power -9. Then you divide by 1,6. And what is the answer?
Answer. 3.125. No, said about 6.
Scientific. Put your calculator on scientific mode.
Yes, ma'am.
It's 3,125
Times 10
to the power
to the power of -4 to the power of 400.
the power of what?
405.
No, you are the one who's supposed to give me the answer. It's 3,125 times 10 to the power 9, is it?
Yes, ma'am.
We don't need these many numbers, okay?
Yes, ma'am.
1, 2, 5 times 10 to the power 9
Yes.
electrons. Okay. So this was for scenario 1. Then for scenario 2, what was the final charge? It was 2,5, is it?
Yes, yes, ma'am. Times 10 to
Times
the
10 to the power
-6.
-6
Yes, ma'am.
divided by 1,6 times 10 to the power -19. And what is the answer?
Answer kube 1,5625 times 10 to the 13.
5, 6, 2, 5 like this.
Yes, ma'am.
Times 10 to the power
Of 13.
13 electrons.
Yes, ma'am.
Awesome. Then for 1.6, also read carefully.
So calculate the electrons gained or lost in each scenario.
You see now, where are we going to find these electrons gained or lost?
Gained or lost.
Where do we find them? In which charge?
In which charge?
Yes.
Guess it's scenario 1 so it's all A.
Well, where is it? Which charge are we going to use to convert to?
1,25 times 10 to the power of 10 electrons.
No, you see, when we say calculate the electrons gained or lost, it's same as you get it from charge gained or charge gained. To charge gained, we said it's change in Q. You remember?
Yes, ma'am.
So it means you convert charge gained, change in Q here. So you will use charge gained, change in Q. Charge gained or lost, which is change in Q over E. Okay? So you go to the first scenario. What was charge gained or lost between A and B? It was?
Between A and B. Charge gained.
Yes.
5 times 10 to the power of negative 10.
Was it not the final charge?
Oh,
That was not charge gained.
Okay. They go 2,5 times 10 to the power of negative 9.
2 times 2,5.
Yes, ma'am.
Times 10 to the power negative 9.
Yes, ma'am.
Divided by 1, 6 times 10 to the power negative 19. So it's your answers in 1.2. So the charge transferred is same as charge gained or lost. So we are converting it now to electrons. Okay, what is the electrons?
Also 1,56 times 10 to the 10.
Just 56.
1,56 times 10 to the 10.
Times 10 to the power 10 electrons. Yes, can you see that?
Yes, ma'am.
Then for the second one, scenario 2.
Yes, ma'am.
What was the charge transferred or charge gained or lost?
We go 2,5 times 10 to the negative 9. Hey, we go 5 times 10 to the power of negative 7.
5
times 10 to the negative 7.
The power negative 7, is it?
Yes, ma'am.
Then what is the answer? What is the answer?
3,13 times 10.
3,
13 times 10 to the power of 12 electrons.
times 10 to the power of
12 electrons.
12 electrons.
Yes, ma'am.
All right. Do you see how it's done?
Yes, ma'am.
All right. Then quickly, another important part we are going to be able to cover today. I realize we won't be able to do everything for electrostatics in one day. All right.
Yes.
Yeah. It takes 2 sessions if I'm being practical. Then the other section now we are going to be looking at, it's Coulombs. You remember Coulombs law?
Yes, ma'am.
Can you remember?
By definition, I don't think I can recall it, but say I'm getting yes.
You remember it.
Yes, ma'am.
But the only problem, you don't know if you can recall or not.
Definition
But those are the, it's principles you shouldn't even forget.
Oh yeah, I'm not getting told it about my long term. It's Electrostatic force between 2-point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between point charges.
Yes, I'm gonna use the current grade 12 exam guidelines, TP. All right, here.
Yes.
So you must be able to state Coulomb's law. All right, if we state this law in symbols, we just say this electrostatic force is directly proportional to the product of the magnitude of the two charges. You see, it's directly proportional and inversely proportional to the square of the distance between them, between these two charges. It means if I've got these two charges here, I've got this Q1 here, and I've got also Q2. Remember, there is a distance between these two charges, distance between their centers. We call that distance R, okay?
Yes, ma'am.
So you calculate the force that these two charges, Q1 and Q2, will exert on each other. So if you look at F, we can draw the graphs of direct and inverse proportionality from this case. F, let's isolate F, the relationship between F and the two charges. We say product because we are multiplying here the two charges. So when you multiply things, you get what we call a what? A product. So F is directly proportional to Q1 and Q2. These questions can come up in the multiple choice. So if you draw a graph here, the graph will look like this. It's a direct proportionality graph,
Yes, ma'am.
which means as the x-axis increase, also as the y-axis increases, also the x increases. So the graph, and it cuts through the origin, which means it cuts through 0. So we will have F here on the y-axis. So it's our dependent variable. We have Q1 and Q2, the product of these two charges on your y-axis, the independent variable. You can see the graph that shows the relationship between who and who, between the electrostatic force and the charges. All right, you can see that one. Okay. Then the next one, it's when we have now F and we isolate R squared now. We focus on R squared and F. So F is directly proportional to who? Or it's inversely proportional to R squared, which means when R increases, when R squared increases, F decreases. This is an inverse proportionality. Now the graph for this one, this is the shape of an inverse proportionality. It's like that. You will have your F again as your dependent variable, and you will have here your R squared. Your focus is strictly F and R squared. They are inversely proportional. But we can easily turn this graph around and make it a direct proportionality graph. How? Look at what we can do to make this graph look like this from this form. We look now at 1 over r squared holistically, which means we look at the relationship between f and who and 1 over r squared. If you treat it like that, you can tell that f is directly proportional to who? To 1 over r squared. That's an inverse of who? Of r squared.
Yes, ma'am.
Okay?
Yes, ma'am.
I hope you are getting these shapes.
Yes, ma'am.
Okay, it's important. Now looking at Coulomb's law equation that we will be using to solve problems. Now, looking at this law, which we have written in symbols, if you want to replace a proportionality sign with an equal sign, you introduce a constant. And the constant here that is introduced is k. So we've got k q1 now, q2 over r squared. Now this is the equation we will be using to solve problems. F is equal to k q1 q2 over r squared. How did we move from the proportionality sign to an equal sign? We introduced a constant k. What is the value of that constant? K is equal to 9 times 10 to the power 9. You will find it on the data sheet. Okay?
Yes, ma'am.
Yes, it's given. It's a constant that will be found by you on the data sheet. So, according to the guidelines, you must be able now to solve problems that are in 1 dimension, 1D, up to a maximum of 3 charges. So you'll find that you will have 3 charges. Here is charge 1. We'll have another one, charge number 2. You can have another one, which is charge number 3. Then this is 1 dimension. You can see all of them are along the horizontal axis.
Yes, ma'am.
Or all of them are going to be along the vertical axis. Let's say we've got charge 1 here, charge 2, and charge number 3. You can see these ones are along the vertical axis.
Yes, ma'am.
These ones are along the horizontal. This is 1 dimension. If we talk now of solving problems, 2 dimensions, also limited to 3 charges. And the vertices of a right-angled triangle, it will be only a right-angled triangle. It means now these 3 charges now are going to be put like this. We can have charge 1 there, have charge 2, and also have charge number 3. You can see these charges. You can see now we have that right-angled triangle. All right. So this is 2 dimension now. Okay. So you are going to be using this formula now to calculate the what? The charges. You can calculate between 2 charges only. You can also calculate between if there are three charges, whether they are one-dimensional or two-dimensional. I just want to quickly show you how to calculate if it's two-dimensional. All right? Usually, okay, also one dimension, if it's three charges, the question it's going to say here, let's say we've got three charges. Let me create a scenario we are going to work with. Let's say we've got three charges. This is one dimension. Let's say it's charge X, Y, and Z. This is 2 nanocoulomb. This is also 2 nanocoulomb. And this is negative 3 nanocoulomb. Then you are given the distance from X to Z as 1,5 meters. Your distance must be in meters. Then the distance from Y to Z is 0,6 meters.
Yes, ma'am.
Then the question says, calculate the net charge experienced by Y. Calculate the net charge experienced by Y.
Yes, ma'am.
What are you going to do? The first step, it means since the question says net charge by who? By Y.
Yes, ma'am.
They put wheels on Y. It means charge Y is the moving one. It's a roving charge. These others, X and Z, are fixed. They do not move. Okay?
Yes, ma'am.
They will not move towards Y or move away from Y or attracted by Y or repelled by. They are fixed. Only Y here will be a moving charge. Okay? So you must check or remember now that charges exert a force on each other. It's either they repel or attract each other. Do you know that?
Yes, ma'am.
Charges exert a force on each other. Remember that one. It's either they attract or repel each other. Now check Y. Y is positive, or X is positive. Y is also positive. Only Z is negative. Now check, what is X going to do to Y? Is it going to attract it to the left or repel Y to the right?
It will repel Y to the right because omabili X and Y are positive, and positive charges repel like charges repel each other.
Okay, so the direction of motion of charge Y will be to the right. Good. Then check Z. What is Z going to do to Y?
It is going to attract to Y because unlike charges I checked down.
Attract it in which direction?
To the right.
Perfect. Before you answer this question, these are 5, 6, or 7 marks questions. Make sure you draw a rough sketch like this. You put wheels on the charge that is experiencing the net force. It's not net charge here, it's net force, all right?
Yes, ma'am.
Yeah, it's force. Calculate the net force.
Yes, ma'am.
Yeah, the charge that experiences the net force, immediately put wheels on it. It's a moving charge. All right, now we've got two forces here. There is a force by X on Y. We also have a force by who?
By Y.
By Z on Y.
Yes, ma'am.
You see now there are two forces by two different charges. Hence, we need a net, which means now you need to add these two forces, okay?
Yes, ma'am.
So how are you going to calculate a force by X on Y? You will say K Q
Yes, ma'am.
X times Q Y divided by R squared, the distance between X and Y. For F by Z on Y, K Q Z times Q Y divided by R squared, the distance between Z and Y, or Y and Z. So you are going to calculate the electrostatic force both by these. Let's do it together so that we are faster. What is K?
Okay. Okay, it's about 9 times 10 to the 9.
Okay. What is QX?
QX is about 2 times 10 to the power of 2 times 10 to the power of negative 9.
QI?
QI is about 2 times 10 to the power of negative 9.
What is the distance between X and Y?
Distance of 0.9.
0.9. How did we get 0.9?
It's a total distance, then minus the distance here, Y to Z.
Excellent. It's 1.5 minus 0.6. So it's this distance is 0.9. Well done. Okay. Then what is the answer?
It's very fun to the times 10 to the power. Okay. What's about 4,4? About 4,444 times 10 to the power of negative 7. To the
Times
power of
10 to the...
negative 8. Power of negative 8.
Which is which?
Yeah, 8.
Please make sure that the answers are correct.
Yes, ma'am.
Newtons.
Yes, ma'am.
In which direction?
To the right.
To the right. Perfect.
Yes,
To the right. It's important direction here. To the right.
yes, ma'am.
Then the next one, we do the same thing. We substitute. What is K?
9 times 10 to the 9.
What is charge on Z?
Negative 3 times 10 to the power of negative 9.
Okay. Just omit negative. You see these equations that have got K, 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 Q, K, what, omit the negative sign so that it doesn't confuse you, okay?
Yes, ma'am.
Then what is Y?
2 times 10 to the power of negative 9.
Okay. Omit it because you will think it tells you about direction when you get a negative answer, and yet it's not so. What is the distance between Z and Y, or Y and Z?
0.6.
Then go to your calculator. Don't forget your squared
Yes,
when you are calculating.
so about 1.5 times 10 to the power of negative 7.
1,5
Yes, ma'am.
times
Times
10 to
10
the power negative
7
7 newtons. In which direction?
to the right.
To the right. Perfect. But you are not done. Remember, this is just force, electrostatic force by each charge. The question says it wants F net, all right?
Yes, ma'am.
Since it's one dimension, it's easy. You say F net is equal to Fxy plus Fzy. You add these two together. It's a sum. Remember, F net is a sum. It is a total, okay? Fortunately, both of them are going in the same direction. So if there was one saying to the left, the other saying to the right, remember you were going to put different signs.
Yes, ma'am.
To indicate that they are going in opposite direction. So the other was going to be positive and the other was going to be negative. Did you get that, Ketelo?
Yes, ma'am.
Okay. Plus 1,5 times 10 to the power negative 7. Yes. So what is the answer?
1,944.
1,944 times 10 to the power who?
Negative 7.
Negative
7.
7 newtons. In which direction?
To the right.
To the right. Each of these forces, write direction next to them. Because if you omit direction, you will lose marks. Okay?
Yes, ma'am.
Yes, to the right. That's how you do it. For F net in one dimension. All right.
Yes, ma'am.
Okay. Then quickly, let's look now for 2-dimension. I sent you the worksheet
Oh, yes, ma'am.
or on your mom's WhatsApp, okay?
Oh, yes, ma'am.
Yes, I will give you homework on that worksheet.
Yes, ma'am.
All right, then let's say now these charges, okay, Telo, now were at right angle to each other. There is X, there is Y, there is Z. The session is over, but I just want us to quickly do this. The same distance, 0.6 meters. Also here, it is 0.9 meters. Okay. Already okay, this is the one with the wheels. The question is still the same. Calculate the net force experienced by Y. So Y still has got the what? The wheels. Yes, tell me X, remember X is positive,
Yes,
Y is also positive, only Z is negative. Tell me what will Y, X do to Y?
it will repel over.
It will repel it downwards. Is it? Now direction is no longer to the right, it is?
Downwards.
Yeah, it will push it away from itself. Then Z, what is Z? Z is still to the
To the right.
right. Okay. So Z is still going to attract Y to the right. Okay. We already know the values. The values. Now, force by X on Y. What is the value?
Force on X on Y.
Mm-hmm.
Ngiyibhalanga phansi.
How can you say you didn't write the answer?
Phela athi bengithi siyenza verbal ngoba phela bengiyi-calculator la ngi-calculator. Noma uthi ngiyenze quickly.
Hey,
X on
so you are going to recall all these
yes.
by heart.
Phela ngibhalile ukuthi in one dimension yiphi formula esetshenziswayo. So I think I should be able to understand. Ngoba phela mekuthiwa calculate the net force experienced by Y, ngiyazi fanele uqale uthole leyo kuqala nale edingekayo, then lesibili nale edingekayo, then uyazi-add-a noma uzi-subtract.
It means now you will have to recalculate this one.
Yes.
You know the answer.
Yes, ma'am.
Then you know X, Y. Now it's no longer to the right, it's down.
Yes, ma'am.
You must calculate it again because you didn't write it. This one will still to be
To the right.
to the right.
Okay.
Or you say east.
Nine times 10 to the power times X on Y.
Here are the answers. So the other one is 4, 4, 4. The other one is 1,
4,4. 1,944.
so it's 4, 4, 4. Then the other one is 1,
944.
1, 5. This one is 4, 4, 4 times 10 to the power negative 8 newtons. This other one, it's 1, 5 times 10 to the power negative 7 newtons to the right. Then since these ones are 2-dimensional, because down is south, that's vertical. To the right is east, that is horizontal, that is 2 dimensions. There is a y and an x dimension there. So we're gonna use what you learned in grade from grade 10 vectors, you know, the tail to head method. You're gonna draw the first vector. It can be any of these. We can draw the first vector, which is downwards, x. There it is. There is a tail. Where there is arrowhead, we say it's a head. Then we draw the second vector, which is yz, which is to the right. Where do we draw it? From the head of the first vector. You draw it from the head of the first vector. Then that's how you draw it. This is f x y, and this is f. Oh, it's not yz. It's supposed to be zy. 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 Force by z on y. Then the resultant, it's gonna be from the tail of the first vector to the head of the last vector. There is your resultant. All right. From the tail of the first vector, which is to the head of the last vector. That is your F net. Tell me, how are you going to calculate that F net?
In Pythagoras.
Yes, you will use Pythagoras theorem. So quickly get on it.
Yes,
F net squared is equal to fxy is 4, 4 times 10 to the power negative 8 squared. That is the theorem of Pythagoras. Then you continue. plus 1,5 times 10 to the power negative 7 squared. Then you will put a square root on both sides to get rid of the square on F net. Then tell me what is our F net.
Iroot yakhona izoba 1,5643 1,5 643 times 10
Times 10 to the power?
times the power of negative 7 of negative 7.
Negative 7 newtons. Then the direction, because we can't say to the left, to the right, this F net, we need to put a north pole there. You see, at the tails. There at the tails, we put a north pole. There is a north. Then we need this angle from here to here until you reach, it's a bearing. So we need that angle. The easiest angle to work out first is this one. That is inside your triangle at the tails. You see that angle? Need to work out that theta. The one at the tails where there is no arrowhead. This one is 90. Not this one where there are arrowheads. We don't work with that one. The one at the tails where there is no arrowhead. So we need to work out that angle. Remember, we know all our sides. Is it? So we can use any trig ratio according to soccer tour. So you use your trig ratios to work out that theta. So what will be our theta? I can use maybe tan theta, which is gonna be opposite over adjacent. Fz on y was 1,57. 1,5 times 10 to the power negative 7 divided by 4,444 times 10 to the power 8. Tell me what is our theta? What is our theta? Theta is 73,51 Ketel. Are you still trying to find it? Ketel? Theta is 73,51 degrees. Then this angle, this one, if we are looking for our bearing, direction now, so our direction is equal to 180 degrees minus 73,51 degrees, which is going to be equal to 106,49 degrees. So the answer here is 1,56 times 10 to the power -7 newtons at, you can say at a bearing, or at 106,49 degrees. These are 9 or 10 marks questions. All right, so that's how we work out a bearing. Remember, a bearing, it's an angle from the North Pole. It's measured clockwise from the north. You move until you reach your resultant or your net force. Then you stop. That is the angle that we've been looking for. And there it is, 106,49 degrees. Now we have come to the end of our lesson. Bye.